We're going to look at the equation of a circle and then of an ellipse. We'll begin with this equation, which as we can see is not in standard form, but some simple completing the square, adding a 36 and a 1 to both sides of the equation helps us rewrite our equation so that it is in a more graphing friendly form. We identify that we have a center at -6, 1, and a radius of a square root of 20, and that allows us to create the graph that we see here. Notice that this graph also involves some shading, and that's because our original equation contained a less than or equal sign. Notice too how we labeled the points that we identified after we had gone up, down, left, and right the square root of 20. A little bit more than 4, but not as many as 5 units, adding and subtracting that square root of 20 to either the x or y coordinates of the center. And finally, we could have written our equation in this form, dividing both sides by 20, so that r squared was now in the denominator of the fractions in the equation. Let's move down now to concentrate on the ellipse. And remember that we can consider an ellipse to be a modified version of a circle. A circle has, in fact, congruent major and minor axes. We can tell by looking at this equation that it, in fact, is not a circle because of the coefficients of the x and y squares. We also know that it's an ellipse and not a hyperbola because of this plus sign. The completing the square in this problem is going to be a little bit more complicated because we have to factor out the 4 from the x terms, the 36 from the y terms, and then we have to remember to multiply the 4 by 25 and the 36 by 16 before we fill in the blanks on the right hand side. But once we've done all of that and then divided both sides by 144, we get our standard form, which gives us lots of information. We can tell, because this larger number 36 is under the x squared term, that our ellipse that you see in this graph runs left and right. To graph this, we move left and right 6 units from the center and up and down 2 units from the center, giving us a major axis that is 12 units long and a minor axis that is 4 units long. I'm also able to identify the focus points for this ellipse using the equation a squared equals b squared plus c squared, and then substituting our values for a squared and b squared. A little arithmetic tells us that c is the square root of 32. Keeping in mind that the focus points are always on the major axis, we move left and right again, this time a little bit more than 5 units, but not as many as 6 to locate our focus points. And notice again how we have identified the coordinates of these points, adding and subtracting the square root of 32 from the x coordinate of the center.